Okay, today we're going to be seeing how close you can get
to MOGIF.
So before we can test this, let's talk about what
MOGIF
actually is. So you have normal stars like our sun, and our sun has a lot of mass. And when you have a lot of mass, mass has gravity and it wants to compress together and it wants to attract each other and compress tighter and tighter together. But the reason our sun doesn't just collapse in on itself is because there's another force that's pushing it apart. And that force is due to the explosion that's constantly happening in the sun due to nuclear fusion. So hydrogen is constantly forming into helium and it's exploding the sun. So this exploding force is pushing it out and gravity is pushing it in more and more together. But what can happen sometimes is if there's enough mass, then the mass will keep collapsing in on itself in the star and it'll collapse more and more and more and more until actual electrons are becoming so close together that they become as close together as they can possibly get, and the only thing that's stopping them from overlapping each other is the Pauli exclusion principle. And the Pauli exclusion principle says that you can't have two electrons in the same place at the same time in the same state. But what happens if you try to force them more and more together is the only thing that's holding them apart is due to the Pauli exclusion principle. But it doesn't stop there. If you have too much mass, the mass still wants to attract each other, and not even the Pauli exclusion principle can keep the electrons from getting closer together. So as it keeps compressing stronger and stronger together, the electrons and the protons get so close together that you have electron capture, and it turns a proton and electron into a neutron. And you end up with a pure
pig slop.
And that's called
MOGIF.
And it's so dense because you no longer have these protons and electrons, but you have just pure
fatness that is not bound by the laws of physics.
So today I want to show you what would happen if you had just a very tiny drop
of MOGIF's colossal fatness. MOGIF has become so fat that it is now eating through the earth, as you can see from this demonstration right here.
In a while, as it falls, it'll eventually just become lodged in the Earth's core.
This will lead to the ultimate death of civilization as we know it, as MOGIF loves to eat.
Okay, now let's redo this experiment with a magic stand that can support the weight of the 100 billion kilograms in that tiny little centimeter cube there. Now, because this is so dense, it has its own gravity force that I can feel. And what this feels like to me is that when I start to walk closer to it, it kind of feels like I'm starting to walk down a steep downhill because the gravity is pulling me towards the neutron star instead of straight down towards the Earth. So I kind of feel like I'm walking down a hill. So even just sitting next to it on a table, it's like gravity is pointing that way towards the drop of the neutron star instead of straight down towards the Earth. Whoa!